What if I told you that right now, inside a handful of research institutions across Europe, there is real, verified data collected by one of the most advanced deep space probes ever launched, and nobody outside those walls has seen it? This information has been sitting in silence for 4 months, untouched by the public eye, and the implications are staggering. Stick around, because what happened next challenges everything we thought we knew about interstellar objects and may change how we understand the very nature of our solar system. If you're fascinated by the story of 3E Atlas and the cosmic mysteries it brings, hit that like button now. Every click helps support the hunt for the unknown and keeps this investigation alive. Before we dive into the events that have scientists around the world holding their breath, here's what you need to know. This story is far from over. Most headlines moved on weeks ago, labeling 3E Atlas as a strange but ultimately routine visitor, a comet that came and went. But in science, silence is never the same as closure. The quiet surrounding what happened in November of last year is one of the loudest signals anyone could possibly hear. And that's why we need to go step by step, piece by piece, to understand why a late March meeting between instrument teams is now one of the most critical events taking place anywhere on Earth, and why almost nobody outside the scientific community is talking about it. It starts with a question. When the most powerful deep space probe ever built, a €1 billion spacecraft designed specifically to study Jupiter's icy moons, suddenly halts its primary mission to point 5 of its most advanced instruments at a comet, what does that tell you? Think about it. Not 1, not 2, but 5 specialized instruments, each crafted for highly technical, precise measurements, redirected simultaneously toward an object completely unrelated to the mission's main goals. That is not casual curiosity. That is an institution signaling that something out there demands its full attention. The probe in question is Juice, the Jupiter Icy Moons Explorer, launched by the European Space Agency in April 2023. By November 2025, Juice was on the far side of the Sun, a difficult communications window with slow data transmission, a period when most of the world wasn't paying attention, and that's exactly when it happened. On November 6th, 7 days after 3E Atlas reached its closest approach to the Sun, Juice's Janus camera captured 12 images of the object in a single session. At the same time, 4 other instruments, MAGIS, SWI, PEP, and UVS, were all pointed at the comet, collecting simultaneous data. Here's where things get strange. Because Juice was behind the Sun, the data couldn't be transmitted immediately. Scientists had to wait, and wait they did, until the final week of February 2026. 4 months later, the complete dataset finally reached the hands of the research teams. What they did next is equally extraordinary. A closed-door meeting scheduled for late March to discuss the results. No leaks, no preprints, no public discussion, just deliberate, almost ritual-like silence. At first glance, you might think, science takes time. Data analysis is complex. And you'd be right if this were a normal situation. But here's the thing. When other interstellar visitors like Oumuamua or Borisov arrived, the world saw immediate public scrutiny. Papers, debates, and discussions erupted in real time. With 3E Atlas, everything has been methodical, coordinated, and delayed. That pattern of silence, combined with the escalation of instruments, tells a different story. It tells us that whatever is happening, scientists are being extremely careful. So what exactly were those 5 instruments looking for? Let's start with MAGIS, the Moon and Jupiter Imaging Spectrometer. Designed to analyze icy surfaces and atmospheres, MAGIS breaks down visible and near-infrared light to determine chemical composition. Scientists spent years calibrating it against known icy moons, so they know exactly what natural compositions look like. Pointing Magus at 3 Atlas is not casual observation, it's a test. It's asking, what is this made of, and does it match any known natural interstellar comet? Then there's SWI, the sub-millimeter wave instrument. Built to study atmospheric layers on distant moons, SWI identifies molecular species with extraordinary precision. When scientists aim it at a comet, they're hunting for anomalies, molecules that shouldn't exist in a normal comet. And there's the PEP, the Particle Environment Package, which measures charged particles surrounding the spacecraft. Using PEP on a comet indicates researchers are checking for unusual electromagnetic activity, evidence that something out of the ordinary might be influencing its environment. 5 instruments, each with a specific purpose, all focused on a single object. And yet, there's no public explanation for why a mission designed to study Jupiter's moons spent an entire observation window on a comet. That gap, that silence, is a story in itself. But anomalies don't stop there. Around the same time, as 3 Atlas moved away from the Sun, NASA's Spherex telescope recorded something unusual, a flare. Normally, a comet dims as it recedes, losing solar energy with its tail fading. But 3 Atlas flared, increasing its output at a time when all standard cometary models say it should be cooling down. Scientists suggested one explanation, a heterogeneous nucleus with pockets of volatile material becoming exposed in a specific sequence. Possible, yes, but the precision needed to mimic a deliberate increase in activity is staggering. It's the kind of pattern that makes researchers stop and reanalyze everything. Even earlier observations added to the mystery. Multiple observatories detected activity resembling cryovolcanism on 3 Atlas. On icy moons like Enceladus or Triton, cryovolcanism is driven by internal heat and geological energy over long periods. But a comet, potentially visiting our solar system for the first time, shouldn't behave like that. Outgassing is normal. Structured eruptions from beneath the surface, that suggests organized internal energy, something entirely unexpected. These observations were briefly reported, debated, and then quietly set aside. And then there was the X-ray halo. Scientists detected emissions extending 250,000 kilometers from the nucleus, about the distance from the Earth to the Moon. Yes, solar-wind interactions can create X-ray signatures, but the extent observed around 3 Atlas was unprecedented. The signal was strong, tangible, and unexplained. Put it together, an interstellar object enters our system, displays unusual flaring as it leaves, shows potential cryovolcanic behavior, emits a massive X-ray halo, and triggers the redirection of €5 billion instruments. The data sits in silence for months, pending a closed-door review. Alone, each observation could be dismissed. Together, they form a sequence no ordinary comet would produce. Now, let's examine the timeline in detail. On November 6, 2025, Juice captured 12 images of 3 Atlas while all 5 instruments were fully operational. Magus, SWI, PEP, and UVS simultaneously collected high-resolution data, each recording distinct aspects of the comet's behavior, from chemical composition to particle interaction and electromagnetic activity. Every system was engaged. The scale of coordination alone is remarkable. This data then sat in storage, inaccessible to the wider scientific community. The delay wasn't accidental. 4 months later, in late February, the full dataset finally reached the research teams. And instead of immediately publishing or discussing the findings publicly, the teams scheduled a meeting for late March. Why? Because the information is not ordinary. Science normally leaks, especially when it involves anomalies. Oumuamua and Borisov prompted immediate discourse. Structured delays signal caution. They indicate that what is being analyzed may fundamentally challenge our assumptions about interstellar objects. MAGIS, as we mentioned, was measuring surface composition. The readings from 3 Atlas could indicate materials never before observed in a comet, or proportions inconsistent with natural expectations. SWI's submillimeter analysis would detect molecules too exotic to appear in a routine cometary body, and PEP's particle environment measurements could reveal interactions with the surrounding electromagnetic field that suggest active energy processes rather than passive drift. Each dataset independently could spark intrigue, but the combination forms a coherent picture suggesting something more extraordinary. Beyond Juice's observations, other instruments had picked up anomalies. Spherex's detection of a flare during the comet's outbound journey contradicts conventional cometary physics. Cryovolcanism signals were noted by multiple observatories, yet disappeared from mainstream reporting without resolution, and the X-ray halo extending the Earth-Moon distance adds yet another layer of complexity. Individually, each signal could be explained, but together they form a pattern, a sequence of anomalies, all pointing to an object that defies standard models. The flares, eruptions, chemical composition, and electromagnetic activity align in ways that suggest an internal structure or energy source that shouldn't exist in a simple icy interstellar visitor. Scientists are observing a phenomenon that appears carefully organized rather than random, precise rather than chaotic. And that is why the March meeting is so crucial. This is where the instrument teams will combine their separate observations into a single, comprehensive analysis. It's a deliberate pause, a coordination of knowledge before the story reaches the public. 4 months of anticipation, held back, not to delay, but to ensure the findings are framed accurately and fully understood. So, let's consider the bigger picture for a moment. The data from Juice, combined with the other anomalies already observed, paints a scenario that is almost unprecedented in modern astronomy. Here we have an interstellar object passing through our solar system, behaving in ways that defy the patterns we've come to expect. Every interstellar visitor studied before followed a relatively predictable script: approach the sun, heat up, release gas and dust, and then gradually fade as it traveled back into the darkness of space. 3 Atlas did none of that. Instead, it flared as it left perihelion, displayed eruptions suggestive of cryovolcanism, and produced an X-ray halo that extended hundreds of thousands of kilometers. Each one of these behaviors on its own might raise eyebrows. A flare during departure? Strange, but possibly explained by unusual surface materials. Cryovolcanic-like eruptions? Odd, but perhaps triggered by internal stresses. An X-ray halo stretching the distance from Earth to the Moon? Certainly rare, but within the realm of physical possibility. But when you take all of these anomalies together and add the unprecedented response from Juice 5 instruments redirected, working in perfect synchronization, the picture starts to look less like coincidence and more like a carefully orchestrated observation of something extraordinary. Consider the discipline required for the teams managing these instruments. Each sensor on Juice represents years of development, millions of euros in precision engineering, and countless hours of calibration and testing. To repoint them simultaneously toward an object that was not part of the primary mission represents a deliberate, high-stakes decision. The scientists involved would have weighed every risk, every possibility, and yet they chose to devote an entire observation session to 3 Atlas. That choice alone signals that this object warranted their full attention far beyond what an ordinary comet would ever inspire. And the silence that followed is equally telling. 4 months of inaction in a world where information spreads instantly is not normal. The scientific process is usually loud, messy, and immediate. Observations spark discussion, papers appear, debates erupt. But here, every team remains silent, waiting for the late March meeting to consolidate their findings. That level of coordination suggests caution, careful evaluation, and perhaps even a recognition that these findings could challenge assumptions we've held about interstellar objects. Now let's add another layer to the story. As 3E Atlas moved beyond the inner solar system, its unusual activity continued to intrigue astronomers. The flare, recorded by Spherex, inconsistent with solar heating, challenges conventional models. The cryovolcanic signals observed, then quietly shelved, indicate structured internal processes in an object expected to be passive. And the X-ray emissions spanning 250,000 kilometers? That's not just an outlier, it's a measurable, substantial feature that demands an explanation. All of these phenomena combined suggest that the comet is not simply drifting through space like a frozen relic of another star system. Something is happening beneath its surface, some internal process or energy source that science has not yet fully explained. The significance of this cannot be overstated. We are witnessing an object that refuses to conform to known patterns, an interstellar visitor that challenges everything we understand about comets, chemistry, and celestial physics. And yet, despite its potential importance, the world remains largely unaware. Headlines have moved on, news cycles have shifted, and public attention has drifted elsewhere. But the instruments on Juice, the observations from Spherex, and the coordinated silence of the scientific teams all indicate that this is far from routine. What's unfolding now is a test of patience and perception. Scientists have held onto 4 months of data, waiting for the right moment to present their findings. That moment, the late March meeting, could reshape our understanding of what an interstellar object can be, how it behaves, and perhaps even what it represents. The full story is still hidden, encoded in the datasets, sitting quietly in the hands of experts who know the significance of every signal, every flare, every X-ray photon captured from millions of kilometers away. As we move closer to understanding the mystery of 3E Atlas, it's crucial to recognize the unique context of these observations. We are not looking at ordinary cometary behavior, nor are we dealing with routine interstellar debris. Every measurement captured by Juice, every flare observed by Spherex, and every anomalous X-ray photon recorded contributes to a narrative that suggests an object behaving with structure and intent. The coordinated redirection of 5 specialized instruments is not a random act. It is a deliberate scientific response to something that demands careful scrutiny. Take, for example, the chemical analysis conducted by Magus. If the readings reveal compositions inconsistent with typical interstellar comets, elements or molecules never before detected in a visitor from beyond our solar system, it would immediately raise questions about its origin and formation. SWI's submillimeter data could complement that picture, identifying molecular species that are exotic, rare, or even previously unknown. PEP, monitoring charged particles, and electromagnetic interactions might reveal phenomena that suggest the object is not simply inert, but interacting with its environment in unexpected ways. Combined, these datasets could redefine the boundaries between ordinary and extraordinary in celestial mechanics and chemistry. Meanwhile, the flare recorded by Spherex is itself a puzzle. Normally, comets diminish as they move away from the sun, fading gradually without bursts of activity. 3E Atlas did the opposite. The flare was delayed, appearing precisely when conventional models predict decline, suggesting internal processes or structural configurations that scientists do not yet fully understand. Then there's the potential cryovolcanism, hinting at organized internal energy rather than passive sublimation of frozen material. And finally, the X-ray halo, stretching across 250,000 kilometers, implies interactions with the solar wind or charged particles on a scale rarely observed. Each of these factors alone is notable. Together, they form a pattern of anomalies that challenge our understanding of natural interstellar objects. The upcoming late March meeting is therefore critical. All these instruments, all this data, will be analyzed collectively for the first time. Scientists will combine their observations, compare notes, and attempt to construct a cohesive explanation. It is a delicate process. Every word and interpretation must be precise, as the implications could extend far beyond academic curiosity. We are looking at a scenario where a seemingly ordinary comet might reveal behavior, structure, or energy sources that were previously thought impossible. And while the world remains unaware, the patience required by these teams is a signal in itself. Science is usually public, iterative, and immediate. Leaks happen, debates ignite, and discoveries are shared in real time. But here, the silence has been deliberate, structured, and disciplined. It suggests that whatever is being held back carries weight, scientific weight, and potentially significance that could redefine how we think about interstellar visitors. So, what does this all mean for us watching from Earth? 3E Atlas continues its journey outward, already past Jupiter's orbit, moving faster than anything built in our solar system could achieve, carrying secrets from the space between the stars. Behind it, in the data captured by Juice's 5 instruments, lies the answer to a question that has been growing since the first observation. Is this object truly a chemically exotic, unusually active comet, remarkable yet natural? Or is it something more? Something that required a €1 billion probe, 5 specialized instruments, 4 months of meticulous silence, and a carefully coordinated scientific review before a single word could be shared publicly. The March meeting will provide the first comprehensive insights, but even then, what we see initially may not be the full story. In science, context matters. Knowing the silence, understanding the pattern, recognizing the deliberate withholding of information, these are clues in themselves. The universe rarely hands over its secrets immediately. It signals them subtly, through data, through patterns, and through the very way scientists respond to what they find. And right now, all signs point to 3E Atlas being extraordinary, demanding patience, attention, and careful observation before its full story can be revealed. Every anomaly we've discussed, the flare, the potential cryovolcanism, the massive X-ray halo, and the redirection of Juice's instruments, is part of a single, interconnected puzzle. Taken together, they tell a story that does not end with a routine explanation. What will the late March analysis reveal? Will it confirm a rare but natural object, or will it point to something unprecedented, something that challenges everything we thought we knew about interstellar visitors and celestial phenomena? That is the question scientists are quietly preparing to answer. For now, all we can do is watch, wait, and pay attention to the subtle signals being left behind. 3E Atlas continues its journey, silent yet active, leaving traces of its passage in the instruments we've sent across the solar system. And when those traces are finally fully understood, they may rewrite what we know about the cosmos. The patience, the precision, and the discipline of the teams involved suggests that what we are about to learn is not ordinary. It is a moment of discovery that has been carefully prepared, waiting for the right moment to emerge. So don't look away. Keep your attention on the story unfolding in real time. The universe is full of mysteries, and some of them are closer than we think. Click on the next video, subscribe, And join us as we follow the journey of 3 Atlas and uncover astonishing secrets from the farthest reaches of space. The story is just beginning, and you'll want to be there for every revelation.